catch up on the races after this. Here's the water pilot. Second week in June. So 70 miles. That's when I got okay. Oh, that's also. Oh, yeah. You were talking this morning. Yeah. I'm excited for it. That's really great. Oh my God. Yeah. That's impressive. No, I ran.
Why is Adrian? Why is Adrian? Exactly. All right. So
He's not here. It's not hard to beat. Yeah. Nice to meet you too. So, oh yeah, no, it's fine. Oh, sorry, that's what you
You're careful, Ken.
Yeah, we're ready. All right, hello everyone. We're going to get started. So welcome everyone to SEC Dispatch. My name is Roman Danilio. I'm co-chairing with Richard Barnes. It's Monday, so it's a little early. So here's the note. Well, oh, no, I guess we can click. So please make note of the note well. There's quite a few BCPs kind of in place there. As you look at that very quickly, if you have any questions, don't hesitate to ask us or the AD in the room. Administratively, we're going to pass out blue sheets. Thanks, Richard Saltz, for being our Jabber scribe. Would anyone volunteer to be a note taker for us? Jeff Hodges. Thank you. Thank you, Jeff. And just to, and would you like a bottle of fizzy water? So just to remind everyone of our ground rules here in the dispatch process, we recommend what the next steps are for drafts. We do not adopt drafts. As we have the conversations, individual presenters are going to come up to talk about their work. Remember, kind of outcomes we're looking to decide at the back end are, is this work you just heard? Is this best fit into some existing working group? Maybe a couple working groups. Let's have that conversation. Should this be new work? So that means BOF. Do we recommend AD sponsorship if they're willing to take it? Or in the negative, should the IETF not take this work? So at the end of each of the presentations, we're exploring that as the solution space. And repeat, we do not adopt drafts here. So we have a really full agenda here. Each of the dispatch items is going to be about 10 to 15 minutes. We would strongly advise the presenters to talk less than kind of 10 minutes to leave enough time for the discussion. If you saw the agenda earlier on the mailing list, we had to juggle it around a little bit to accommodate other constraints for some of the presenters and other working groups that they are attending that are happening at the same time. So there is the order for us. And at the end, we'll just do a quick wrap up. Would anyone like to bash the agenda, realizing we do not have time to put anything really onto the agenda for discussion? Okay, in that case, first up, Hank, you're gonna talk about the terminology draft on remote attestation. Yeah, right.
Yeah, we're going to do these first two kind of as a group. So let's do Hank and then Lawrence and have clarifying questions, and then we'll have discussion after the two presentations.
Yeah, well, that makes sense. Hi, I'm Hank. And thank you for that. Am I booming your ears out, or is this okay? Okay, excellent. Oh, I have a monitor, excellent. Yeah, this little presentation is about on the different kinds of rodents here in the IETF, which have to be addressed. Rodents is, of course, a pun that is referring to remote attestation procedures. There's a lot of work going on here, and I'm presenting today a specific one that will be discussed also on Thursday after the last session in Square Dorchester in a bar off. And it is the remote attestation terminology. So attestation is being used basically by every SDO in some kind. W3C uses it for web authentication. I think the specification in the web internet has the term attestation like 500 times in the document. And still, it's totally something different than the trusted computing group, for example, thinks or specifies what attestation is. Or in this case, I would like always to highlight remote attestation to other parties. So, and I'm providing here a preliminary definition. So in most of the contributors to the IETF in the last 1.5 years, remote attestation is the procedure of providing cryptographic evidence, which is basically a proof that a system entity is a trusted system or a trustworthy system, which both terms are defined for ages now in RFC 4949. And let's go a little bit on there. It means that the system is exactly doing what it is intended to do and nothing else. And this proof that it is a trusted system, it conveys in a secure manner via an interconnect, which could be, I don't know, a GIO pin or the internet, to another entity or other entities. So effectively, these three activities, we call them here, that are typically tightly coupled due to the use of a nonce and the challenge response scheme, that is the attestation itself, the creation of evidence, the conveyance of evidence from the attester to the verifier via the supposed interconnect, which could be, again, very close or very far away. And then a verification process that somehow assesses this evidence and to establish the actual trust in the entity creating the evidence. So remote attestation basically is a composite of all these three activities, which are typically tightly coupled. And now there's work in the IETF that decouples the time points of where the evidence is created and maybe conveyed years later and still able to be verified appropriately. So there were some terms back in the days that's like a statement of health, let's call it system health to be more agnostic, and trustworthiness and freshness. So this is a reference model basically. I stole that from another draft. This is not from the attestation terminology, but it shows you basically how this works. So there's a nonce in a handshake, and this nonce is somehow processed by the attester that is creating the evidence. And therefore, the verifier knows, oh, this is probably recent. I just gave you the nonce. You gave me evidence. This nonce is somehow included. I guess this is from me. This is now. This is fresh. So here we stand. There is a document, which is the attestation terminology. And we try to consolidate terms here, and roles, and entities, and processes, and so-called activities across work in the IETF. And there are now about, I think, 10 drafts already, including use cases coming from an ETSI liaison relationship regarding NFV. And so current work in progress on that draft is maybe there's more than one kind of hardware root of trust. There might be a root of trust for measurement, there might be a root of trust for storage, there might be a root of trust for reporting, and all those sound somehow it's the same or different, and so there's confusion about this. There are also multiple ways to prove freshness, and maybe the entity that creates the evidence is not the claimant that creates the content of the evidence, for example. So multiple roles are not in yet. And maybe all this terminology should also be somehow interoperable with other work that is not about attestation. For example, new forms to create identities. Yeah, more details. And then we already have an email list, which is easy to know. Remember, it's the RETs at the IETF. And we also have a place to look at, which is a GitHub repository called IETF-RETs. And if any of you somehow is interested in providing some proof of integrity that you are actually healthy and the party you're talking to should believe that, maybe join us on Thursday for our BOF and talk about what your requirements are in this domain.
So if there are any clarifying questions, please ask them now. Otherwise, we're going to allow Lawrence to present kind of next, and then together we're going to have the attestation draft conversation. So any clarifying questions? Okay, Lawrence, come on up.
Thank you. So this is a proposal to undertake some work to define a format for an attestation token. The purpose here is for a device of some sort, referred to as an entity, and the scope here, what's possibly a device, is quite large. Could be a desktop PC, an electric meter, a phone, parts of a car, a whole car, and to collect some information about that entity, sign it with a key or in some form, could be ECDAA, for example, not just straight up signing. Give it to a backend, such as a risk engine or IoT backend, or perhaps other components, maybe in the case of a car or other infrastructure. And the backend looks at this set of claims, verifies the signature, understands who did the signing and how that was secured, and makes a decision about what they trust the device for. Perhaps it's a matter of deciding between a $50 and a $500 transaction amount, or perhaps it's like that we trust that reading of the electric meter. So we're out to try and avoid or understand, if device has been tampered with or cloned, or it's emulating a real device or something like that. The notion is that all claims are optional, because otherwise we're going to have an awful discussion about which claims are mandatory, because I don't think we could converge on that. This is one proposed attestation flow. There's other ways of doing this, and I think we're going to have to accommodate many other flows just because of there's some complexities in the way this works. But the first step is for the manufacturer of the entity to put key material into the entity itself. This is done once during manufacturing. Perhaps this is EPID, perhaps this is an RSA, private key or key pair. Perhaps it's just using TPM-based technology. Trying to be fairly open here. When the device is asked to produce an attestation, I'm not showing it here, but there would be a nonce going from the relying party to the device. The claims would be collected, signed, passed on to the relying party. The relying party would then undergo a verification process where probably they get keys from the entity manufacturer, but possibly they send the token to the manufacturer for verification, or a service in between. Out comes the verified claims, and then they look at those, they put them into their risk engine, along with maybe other things they've got in their risk engine, and make a decision about what they're going to do. So the proposal is to use COSE and CBOR for this. COSE is a nice, small, works for IoT devices. Modern crypto allows for all the variations you need in signing algorithms and whatnot. Gives you the rules for how you know what's signed and what's not signed and all that. CBOR, because it's nice and compact, it allows you to label the claims clearly, has representations for all kinds of different data you might want to put in claims. In my vision of claims is some devices, maybe you have 2 claims that are integers. Other devices, you have 50 kilobytes of all kinds of stuff that somebody thinks they need. So really wide variation here, right? CBOR does nicely for all of that. On signing, I believe because of device manufacturing issues, there's going to be a lot of variation in how the signing goes. For example, how do you put a key into a chip where you have to put that key into fuses, and anything more than maybe 256 bits is too expensive. So it tends to drive complicated manufacturing processes. There's also the issue of privacy in the signing, because if you have a unique key per device and you're signing, that can reveal the identity of the device. So that drives you to things like ECDAA and whatnot. So mentioned some similar technologies. FIDO or WebAuthn, as Hank mentioned. Android Key Store, I think, is also very interesting to look at. It provides attestation of public keys in the key store. And then I won't mention the others because they've been mentioned already. Oh, that was the last slide? Oh, okay. I had a longer deck, but got our decks mixed up, but that's okay. That was most of it. The one other thing I'd like to say here is I think, let's see, from a standardization point of view, it's those things. It's what I'm particularly interested in. What are those claims and what do they mean? Because if we can all agree or partially agree or somewhat agree on some sets of claims and what they mean, then you get the interoperability of these tokens in a broader way. So to me, that's probably where the large amount of work would go in this particular effort. And then one last thing is the idea is also that this is not a protocol. This is intended to be dropped into extensions in other protocols, like put into HTTP headers or as a FIDO extension or something like that. So I'm not trying to define any protocol. I really want it to be an extension. All right, thank you.
So stay up there, Lawrence.
All right.
Don't forget, hang back. So one thing I'd appreciate if you guys could kind of briefly contrast these 2 efforts and see kind of what they have in common and what's different.
Well, so I think that in common, the idea of the flow, the basic flow, and you have some claims, and you're going to sign them, send them to a line party, and they're going to get evaluated. There's some key material that's pre-provisioned. That seems in common to me. When I looked at your slides, and that seems very much in common to me. I'm not particular about a hard definition of attestation. I want to solve the problem or provide something useful, whatever we call it. I know there's a lot of different ideas here. I know rats seem to come out of NSF. No?
Yeah, we incubated there because the very first attestation-based draft was already there, and there was no other place attestation was even mentioned at that time. So that's why we started there, but it's not our actual home. I think we are supposed to go somewhere else, I think.
Maybe another compare and contrast is EAT is coming out of Trust Zone, kind of Android environment, where RATS is probably more oriented around TPMs. Is that a fair statement?
That is about every ESE, also embedded secure element or hardware security model. It's basically about hardware root of trust. That is a basis for authenticated boot, and therefore having a notion that is your provable trusted system. So this is the core of the remote attestation, yes.
In the interest of time, if folks have ideas, please do come up with the mic
Yeah, sure.
and share them.
So I'm sorry, I think I've tuned out for a second, but is this intended to support mass signatures the way FIDO does?
So again?
So FIDO things are, devices are assigned in groups, so that basically you don't create a super cookie with attestation. Would this support that?
Yeah, it could. It could and it should, yes. I'm being purposely vague about signing schemes because we need to accommodate, or open, I should say, about signing schemes because of things like this.
Thank you.
I can add to this that we adhere to 4949, which allows for group identities. So that would be the basis for the signature and the trust you provide. We have a group of entities that is a group entity.
Sorry, you said 4949. What is
4949 RFC defines identities and has a subflavor of group identities.
Okay. I mean, so the way this is in FIDO is this is batch 255 of tokens that consists of 4,000 tokens, basically, right? This is any one of them, and if one of them is compromised, you have to revoke all of them, basically, right? So, okay.
I would just remind the folks coming with the mic, if you want to separate, provide different feedback for the terminology stuff versus the token draft, kind of by all means do it. Don't necessarily lump it together because we lumped it together in the agenda.
Right. So my first observation is that this EAT format smells a lot like JWT. And there may be lessons learned there, quite possibly transliterated.
CWT, yes.
Yes.
Yeah.
Yeah.
Absolutely.
And so that part you can probably leverage or even work with.
Yep.
The rest of the attestation thing sounds a little bit more different.
Right.
I know that when working with JWT, one of my biggest frustrations has been the lack of designation of what the claims mean and a need for more language around that. So
I think Lawrence missed the highlight. This is a COT. This is literally a CWT, right? Your entity attested token.
Yeah, so we actually propose using the same IANA registry for the claims as CWT. But the reason I wanted to separate it is because we're actually trying to prove something about something different than CWT is trying to prove. And we're going to run into issues of like how the keys are provisioned and handled and what they mean. The claim sets are going to be different, and there's going to be a lot of things that are going to be different, and I don't think it makes sense to combine the work.
it may be worth some effort to see if there's a unite.
Yeah, absolutely. No.
Yeah, it's Stephen Banghart. I just have a couple quick clarifying questions. So the chairs put you guys together, you're standing both up there. Are these efforts that work together to get to this point? Did you talk to each other? Does the terminology for this, or are these like competing? Are we going to toss one of you in the lion's den after this? I'm trying to understand the relationship here, and it's not clear to me.
Okay, we're friends, first of all. So,
No, we just met like yesterday.
yeah, but we talked a little bit beforehand.
Yeah,
so
Okay. So maybe you're open
aware.
to working in this, and I think this is more, EAT is more of a single thing, while RATS is more of an effort. Is there any kind of merge plan here? Can you guys work on this together? Is that possible?
That's a little bit of what we're trying to do.
Yeah.
Feedback about what-
Actually,
Yeah, I just want to
and this
understand
is
that.
my fault, I guess, because being not informed enough. When I sent out the invite to the Rats Barboff, I was friendly reminded that there's an EAT BOF, and I was like, oh, interesting.
So there's
I should
both
have
an EAT
known this
BOF
beforehand.
and a RATS BOF?
So yeah, but
Okay.
the scope is different because you're deliberately trying to be an extension and being used by multiple things, and we are trying to scope the multiple things that belong into the IETF. And we have a set of protocols like time-based, peer-synced, and challenge response-based, Yang modules, reference interaction models, all there. But we have to find out how does this curious thing, this is the inbox API, mix with the actual protocols we create here.
Okay, well, this seems minimally like an opportunity to synchronize terminology, if not the actual functioning of these things, especially given that Hank has written the terminology draft.
Yeah, that's why
Maybe work together on it, or something like that would be good.
This is Richard Barnes from the floor. So one way, and this seems pretty significantly different from something like JWT or CWT, is that with these attestation things, you have a significant replay problem. You know, usually we just tolerate that when we're passing around identity tokens. But with these things, if you're feeding it into a risk engine, you want some real assurance that you're talking to the thing to which that attestation belongs. So do these schemes have some mechanisms to accommodate that risk and to deal with it?
I don't think I understand the problem and some of how that would be addressed, but I don't think there's anything per se in the draft right now.
Okay, so for instance, in WebAuthn, I'll call it to use the proper name. there's the attestation certificate that, has a bunch of this stuff that talks about what the device says. And then there's a signature using a public key in that certificate over a bunch of data that binds it to a specific
Right.
instance of the attestation.
Yeah. Right.
So would the focus of this work be both of those parts or just the kind of moral equivalent of the attestation certificate? I think there could be value in doing both of those. But I could also see an argument that it's only worth doing standardizing on one of them because you might have
I
different
think my
signature
answer is
schemes.
yes.
And maybe I can add to this. This is a known problem. So the relay attack basically stealing in this case, the token and just presenting it yourself.
Right.
And there's no way to basically prove that you're talking to the trusted entity here.
Right.
And that's a generic problem. And
Yeah, and I wanted to follow up your thought on that.
Go to the mic.
yeah, sure.
So, Mike Jones, Microsoft. I'm just going to respond to your format comments. JOT or CWT can represent any set of signed claims. I think what you're doing is a profile of CWT. And if you think it's not, come talk to me because there's no reason it shouldn't be.
Okay. Let me think about that. Yeah.
Oh, Gary, my name is Qualcomm. I'm one of the authors of the EAT draft. So, Richard, in response to your comment on anti-replay, because we leverage the Seaboard Web Token, Mike's draft, the claims are extensible. And two of the claims that we can add are the client data hash and the authenticator data, which are critical for keeping the attestation fresh in WebAuthn. So, and in fact, that's one of the beauties of using a JOT or a COT is that it is extensible. We may lay out a basic claim format, but I think when you start looking at it in terms of WebAuthn authenticators, you'll probably want to augment that in that context.
And I just wanted to be Chris Comcast. I'm not sure I got that the first time. I wanted to be clear that even if we decide that the EAT is not work that we want to do, I think the terminology is of incredible value, and we should absolutely put that somewhere and get it done.
We're going to cut the line at Hannes.
Kyle Rose, Akamai. The problem being solved by remote attestation is specifically the one where you don't already have a secure channel or secure channel with the client or trust in the client that you have not yet established that the client is who it says it is, right? So in that sense, it's not the same as the problem that's typically solved using JWTs or CWTs. And so I'm a little bit worried that focusing on the token format is kind of like bike shedding, when what we really need to solve is the remote attestation problem where you're essentially bootstrapping trust in a device that you don't already share a secure credential with. You're essentially using a piece of hardware on that, essentially like a beachhead on that device to decide whether you're going to trust it or not, and then tying a credential that device has created to a specific secure channel, whether it's a key or a TLS session or something like that. So I feel like the focus on RAT seems to be more towards solving the problem. I'm not sure that the precise token format is all that important.
So one of the reasons I picked that was knowing through working on FIDO and other things how many issues there are trying to solve that are sort of deep in manufacturing, and it seemed almost intractable in the IETF context to me.
This is Hannes speaking. We support the EAT effort simply because, as Lawrence, you just stated, there is a format or container problem that we need to resolve in order to pass that information from the device to the different parties. How the keys are distributed in most of those cases will be really during manufacturing. So I don't think that we, other than providing some nice text, will provide a lot of standards on how the manufacturing line actually gets keys provisioned during that time. And also, similar to the FIDO specifications, there are different ways or different signature mechanisms, like sharing the same key among many different devices and thereby providing some anonymity protection, or using some elaborate group signature schemes to provide the same guarantees in a different way. But I think there's a fairly targeted effort here. And as Mike said, it's a profiling defining of a CWD, defining some new claims that shouldn't normally be so super complicated. And we can, or at least a couple of the involved companies can actually roll this out. And we would like to be part of that effort.
And to close that up, I'm a big fan of semantic, well understood, and interoperable claim sets. So to be clear about that, I actually support both the representation and also the cozy signing mechanism. That is a great idea to do it, and I would do it at every place possible if it would be possible. But unfortunately, some of the work that is out there is still TLV, and the signatures won't really match that new token. So, but we found out deals with that even with CBOR created structures that are not necessarily close to that. But this is only migration, I think. I think where we want to be is actually using claimed sign sets and signed claim sets, sorry, using COSI in a broad scale to basically support that interoperability. And so I'm with you there, absolutely.
So what we heard coming up to the mic were a couple of things. First, we didn't hear anyone running up saying this is not an area we should be exploring at all. What we also heard was what we didn't hear, I'm sorry, is anyone saying that's clearly in this working group or that working group or in another working group. And what this leads us to kind of suggest here is this is probably a BOF. There's clearly some meat here. We need a little more discussion to kind of flesh that out. It's not naturally fitting into any existing body of work.
Okay, sure.
Any reaction to that? Yeah, there's already a bar off.
Yeah, so there's a bar off. You guys said, when is the bar off?
Monday?
Yeah, so
Today?
So today at 1800 after this.
Okay.
And then that's eat, and then rats is
Thursday after afternoon session, which is 7:15. The zombie slot.
Yeah.
But there will be beer.
Great. So there's two bar offs this week. If you want to drink twice. And then we'll look forward to a BOF proposal if you guys get some
be for Bancroft or
for Bancroft. Yeah.
If you send a note to the mailing list, the SECDISPATCH just to remind everyone when there's a process.
okay, sure.
Yeah. I mean, if you want to try and move faster, I personally would be interested in experimenting with a virtual BOF, but I think the AD might require some convincing.
Is that so? Thank you.
Thank you. All right, next up, we have Diego.
This is okay. So there was some concerns that we had too many slides. I will try to be fast. Basically, it's about introducing a draft that is complementary to another one that is being discussed in ACME, and that we expect to go for a working group, let's call this, during these days. Well, just to for setting the ground, we are using three elements here. One is what we call the IDO, the identity owner. The other one is the NDC, which is intentionally reversed the CDN because this has been originally thought for the case of CDNs. And basically the CA that you all should know what means. The idea basically here is about the possibility of that the IDO delegating the identity to, the IDO delegating the possibility that the NDC can use a certain private key to prove the association of this private key to the delegated identity by means of a certificate. In the case, and this is in which all these are started, is in the case of the relationship between CDN provider and content provider case. The scope is when, for whatever the reason, you're not using your rewriting or redirections, so you are accessing directly the domain name,
and the certificate, and the domain name is hosted elsewhere. So you want to verify the certificates. The idea is that this is a two-side protocol because you have three entities. You have the CA, you have the IDO, you have the NDC. And the idea is that, we have been working on one of the sides of the protocol inside ACME. And the idea is that when we started defining how the requests should go, historically, we started with this inside ACME, but then we're asked to come here just to see whether there was a general agreement that this belongs to ACME or not. Well, apparently, apart from that, the reason for standardizing it is clearly we are talking about different organizations, different relationships, several IDOs working with the same NDC, several NDCs serving the same IDO, etc. So as I said before, the idea, all this was in a single document that was submitted to ACME. When the ACME document, ACME Star, was adopted, there was a suggestion of splitting both parts of the protocol, and it was not clear, there were some doubts whether the requests themselves really belong to ACME or not. The other side, on the side of the ACME is an ACME extension, in the side of a request is not such an ACME extension. So this idea that to show you how it works, I will be fast on this. You have the IDO, the NDC, the CA, there is relationships among them. You can establish a trusted connection from the NDC to the IDO, and the IDO and the CA run the ACME protocol. The draft is about precisely how the NDC requests an ACME certificate through the IDO, because it's the one that has the trust relationship with the CA is IDO. The CA never sees the NDC. It's about delegate me a certificate for a particular private key, then they issue a CSR template, and the IDO is able to analyze it and match it with whatever the policy and the agreements the IDO has with the NDC. This is ACME with a fused extension, which is this ACME Star thing, that is this draft I was mentioning before. The CA issues following the ACME protocol sends back the request, and something that is important is that in the request there is a period and a frequency, because we're talking about, and I forgot about this, I'm sorry, we're talking about temporary certificates, very short-lived, that are automatically renewed. Because one of the essential mechanisms is that periodically the NDC, using ACME, downloads the certificates and updates it. And at any moment, and this is the other part that is important, which is essentially is equivalent to a revocation, the IDO at any moment can, using the ACME Star protocol, request to invalidate this, and then the NDC is not able to download any more the refreshed certificate, and the certificate becomes invalid. Let me say this is equivalent to a revocation. Well, just to finish, why we are here, as I said before, historically this was part of the ACME Star draft. We were requested to separate it. We separated it. Now that ACME Star is mature enough, we need to complete this. We would like to have something that is, we would like to have a detailed security scrutiny going out of a working group, since that we have the impression that the scrutiny will be lower. On the other hand, and this is why we would like to go to a working group, and in particular to ACME, which is what seems the more natural place. But on the other hand, it's true that for requests can be separated from ACME Star, because ACME is not necessary, but it's sufficient for supporting this, and theoretically other protocols similar to ACME could be used as well. And that's all. I hope time was okay.
Ted Hardy, a clarifying question on your previous slide. So in this particular case, the fact that IDO and the certifying authority are cooperating does not actually require the certifying authority to be using ACME to deploy certificates, right?
You mean for this?
Yeah, so the CA here, if it's doing its certificate management without using Acme, can it still use IDEO?
In principle, yes. The point is that right now, how we have specified the whole flow between the IDEO and the CA is using this extension to Acme.
Okay, so I think a natural question to the room then, is there any indication of use outside of the Acme world? Because I think that might affect where you dispatch this.
Oh, yeah.
Yeah, Martin Thompson. This looks very much like Acme to me.
It's Acme. It is.
So, but at the high level, yes. But I read the draft and it isn't Acme, which is weird. Why did you choose to effectively design a new protocol here?
Because we were considering this case, as I said before. It's not that you are asking. I mean, you are the owner of the domain. If you want Acme to sign something for you, is that you want to Acme to sign something for a third party that is going to use a private key with a certificate.
I don't think that's fundamentally any different. So you imagine that this third party gets you a CSR for a private key that it owns, and it talks to this middle box and says, "Hey, I'd like to create a new order." And there's no authorization required other than the fact that it's got client authentication at the TLS layer, for instance.
No. But this is not happens in the middle of TLS. We're talking about just generating a certificate.
This is generating a certificate.
This is generating a certificate.
If you go back a little further, you've got this arrangement here where you have the box that has the key asking for a certificate for from the middle box.
No, doesn't. I mean, not that middle box. That's the owner of the domain.
Owner of the name. Yes.
This is the owner of the name. It's not a middle box.
That's what I'm saying. Yes. So Eka points out this is effectively like an Acme back-to-back QA in the sense that there's an Acme here and there's an Acme here, and maybe sometimes you can avoid the middle box in some of these interactions.
Let me insist on one thing. There is no middle box.
There is a middle box.
No.
IDEO is a middle box.
That's the owner. I mean, that's not the middle box.
Let me see if I can clarify. Let's not talk about terminology here for a second. A middle box. The point is that the IDEO is telling the CA to give a certificate to the NDC.
Exactly.
And so Martin's point, as I understand it, is why don't you speak Acme on both sides? Why doesn't IDEO act like an Acme server?
But in what both sides? You mean the start request?
I've probably answered. If you want to do
it. Please.
Because the IDO needs to provide the proof that the identity and the name, in this case, the DNS names, is under its own control and not the control of the NDC. So the challenge, and response.
That's fine. Okay, right. So my point here is that if the NDC talks to the IDO and asks for a certificate, no challenges are required by the IDO other than whatever authentication it decides to. It can be authentication. It can use TLS client certificates, or it can use whatever it wants. Challenges will be passed between the CA and the IDO. The IDO will answer those challenges and do all of that business.
Yes.
But and it will gain those authorizations and can then make a certificate request. It just happens to use the CSR that was provided to it by the NDC.
Yes.
That's a alphabet soup right there. But anyway, and then returns back a pointer to the CA in its final response saying your certificate's over here to the NDC. And so the NDC can then talk to the CA directly to get the certificates because there's authentication there. So none of this requires any changes to ACME as far as I'm concerned.
Yeah.
Oh. What are we talking about again? Yeah. So why is there a protocol is the question. So what new is being added by this work?
The fact that someone can talk to that guy, right? Using a standard mechanism. And so
Martin,
the CDN can have...
I'm trying to understand you. You're saying that this could be ACME as well.
No.
Can be. I mean, you know. No.
Sorry, I did not mean to interrupt. Please don't. I don't understand what you mean by Acme, because there's no challenge response on that side.
So
how
what
do
you mean?
prove-
What you
what
mean
will
is
you
that would
prove?
be
What do
a,
you prove?
no. I mean, no. This is something. No. That's a point. I mean, he has a point here. So no, is that no? It's something. No. Seriously, no. At the end, yeah.
I think, yeah.
I saw.
Diego's got it. So the point here is that Acme is a number of things, and that involves the management necessary to create orders and do all of that business and manage the issuance of certificates. The challenge part is entirely optional, in a sense. So
no.
if you don't need challenges, don't use challenges, and you have everything you need already.
No, but Thomas. Yes. No. That's an interesting point. Yes.
Ted Hardy, I think this actually clarifies that this definitely should get dispatched to Acme, which might tell you that we can simplify it down to just using Acme with NDC to IDO back-to-back user agent form.
Ted, sorry.
Yeah, so I think the work definitely does get dispatched to Acme, which might be able to simplify this down to here's how you do this if you want to run a back-to-back user agent where the NDC speaking to the IDO uses a non-challenge form of Acme, but instead some other form of authentication.
It's well, the good point of coming here is that originally Acme didn't say that, so that's fine. I mean, we have widened the audience, and then we get this feedback. Fine, and it's good.
Yeah. So I'll just add another benefit of making the star request have here at Acme is that if you're a CDN and you've got some customers for whom you're doing this dance and you've got some customers for whom you're getting the CA the cert directly from the CA,
so it
over Acme,
it
then just becomes a question of which URL you point to.
No.
It's all just Acme either way.
Yep.
So yeah, I think speaking not
Conclusion reached.
yeah, with Chair Half Head on, I was just like reframing this as an Acme B2B UA informational document. Here's how you configure things, and I think that can be passed through Acme.
No, definitely. It's good.
Okay, so
Great.
a lot of robust discussion, dispatch to Acme. If someone wants
Well, no, I'm probably forget that the whole thing because it's going to be an Acme profile. So that's something that's well. Thank you. Well, I don't know what Rich is looking like. Not.
I'm just looking whether anyone at the mic is going to say anything to the contrary.
Yeah. So no. We got some people who haven't given slides, so be ready to talk for 5 minutes tomorrow.
Okay. It will be you, Thomas, not me. That's next time.
Whoever. The slide count.
Okay. Thank you.
Thank you. Okay, next up on the agenda, Kyle. We're going to be talking about asymmetric manifest-based integrity.
Hi. So Jake Holland, my colleague at Akamai, and I have proposed a new authentication scheme that's intended for multicast. I'm not going to stand up here and explain to you why multicast is useful. There are two obvious use cases that we're interested in, like software downloads and video. But there are tons of uses for multicast, obviously. But what is the problem that multicast has? Well, the big problem it has is that interdomain multicast has security issues, which is a polite way of putting the problem. It's susceptible to injection attacks. Even if you do path filtering or BCP38, you're still subject to man on the side or man in the middle attacks. So what we would like is an integrity scheme that satisfies the following requirements: line rate verification, the use of asymmetric crypto, which, as I'll discuss a little bit later, precludes the use of something like Tesla. We also need it to be efficient, right? We can't the sort of oblivious solution or naive solution of just signing every packet is not going to work because you have low power devices downloading large videos, and it needs to authenticate every packet before it displays it. That just wouldn't work. And we also want it to be loss tolerant. So we need, for multicast, you're going to assume that some of the packets are going to be lost, although we'll have to do some analysis on what the profiles of that loss are, because we suspect that it's not uniform. So the scheme that we came up with in the draft that we posted here, this is the simple version of that scheme. So you essentially have an anchor that has a public key in it. Just assume for the moment that this anchor, you've received this anchor in a secure way from some entity that you trust. The manifest is a single packet that contains a signature of itself and the and hashes, packet IDs and hashes of the data packets that are sent asynchronously. So the idea here is that the manifest uses one signature, one asymmetric signature, to provide integrity protection for all of those data packets. Now you can see immediately the problem with this is this limits your data rate. If you're using 32-bit hashes, 32-bit full hashes, and even if your packet numbers are implicit, where you don't have to include them in the manifest, you're still going to run into a limit of about 40 packets of integrity information per manifest. So that works out to, without any redundancy, about 2.5% overhead, and we can do a lot better than that. So the next step would be to have a manifest tree where you have the root manifest that's signed, have integrity information for child manifests that themselves have integrity information for the data packets. And by extending this, you can increase the bit rate almost arbitrarily, but there are a ton of problems with a scheme like this, because if you lose any single packet, you lose the ability to verify the integrity of all the data. So you can imagine doing something like this, where you have a rolling root manifest where if you lose one root manifest, you're fine because you've got others that will cover the same data. In this case, you have the first root manifest on the left there provides integrity information for the first 3 child manifests. The second root manifest provides integrity information for 2, 3, and 4, and and so forth and so on. And so if you can imagine extending this further, I didn't produce a diagram for this, where you would have the child manifests also roll over a window of the data packet, so you would have enough redundancy under expected loss conditions to be able to cover all the data packets. Ecker?
This is your proposal you're actually suggesting?
We're suggesting something a little bit more complicated than this. This is dumbed down a little bit from the draft just so that I can explain it up.
Sure. Okay. So I guess you suggested several use cases. You said audio and video and software download. Those are quite different in the sense that software download, I actually have to get all the bits eventually, and so typically you just supply a signature that covers the entire body, and then you don't need to worry about.
Sorry, I guess I didn't fully describe the motivation for doing interdomain multicast, right? So if you have a popular software download,
sure.
Let's say there's a new OS update or something like that, and you want to distribute that to millions of people at the same time, it would be nice if you could use multicast to do that.
Sure.
Right. I mean, and in that case, if you lose some packets, if you lose some data, it's not a big deal. Then you just go unicast those individual packets.
No, I understand, but why not simply provide integrity protection over the final data? Why not have a signature at the beginning or end of the object?
Good point. But for live video, you don't have that possibility, right?
Right.
Because the video is being produced at the time.
I understood. Yeah. So there was some work a while back on this by Modugu and Benet for live video. But I mean, I guess I'm really surprised to see you. I thought you were not going to do trees, but once you're doing trees, why don't you just do a Merkle hash tree?
Well, right. So that was actually what I was going to get to at the end here. So the idea would be to use a Merkle tree-like structure to have the integrity information inside each data packet. That complicates things. One of the reasons why we didn't decide on that initially is that requires a change in the data format. One of the nice properties of this is that you can provide the integrity information in a separate channel and not have to modify the data. You can use any existing multicast transport and just kind of tack this on.
Sure. Yeah. So I guess the second issue, and the reason I think, if I'm remembering the Modugu Benet work, was quite a while ago. One of the concerns is latency. So, what is your latency budget?
So we are thinking. I think I don't want to tie this necessarily just to live video, but for the live video use case, there's the hand wave latency. So basically, when somebody waves their hand, how long is it until people see it on their screen? And so obviously you need to authenticate everything. You need to authenticate a segment of video that is at most the length of the hand wave latency.
Right. I mean, I guess
you're going to authenticate, say, 2 seconds of video or something like that. You can't play that until you have all that video and have the authentication information.
Right. But I guess how long is your how long is your jitter buffer? I mean, how many packets? I mean, that's 100 packets. I mean, basically, I mean, it's like, I mean, you just consumed all my latency with your signature scheme, right? So I guess my point is like that you say you can only get 40 packets or so within a within your latency budget.
Well, just do like 1400 divided by 32, right, or something like that.
Sure. Sure. So, but I guess the point I'm making is that like that number of packets is about the number of packets that like anybody's willing to have in their jitter buffer.
So I'm gonna cut the line here after Russ.
Yeah, Martin Thompson. My question was, this seems fine for something that's pre-recorded and you have all the information up ahead of time, but this latency budget is terrible. One-time passwords might be the way you get around it, but that's not really. That's Tesla, right?
Yeah. So I can explain one of the use cases that we were trying to address that Tesla doesn't. So Tesla achieves asymmetry essentially temporally, right? So it doesn't release the key until after all of the recipients have had the data delivered. So that's how it prevents one recipient from impersonating the publisher.
Right.
That doesn't work if you want to use the path to filter out injected packets, because you can imagine a situation in which a client has very limited bandwidth. And so an attacker starts injecting packets into the multicast path and blowing out that client's ability to download, but maybe the intermediate system doesn't even know that this is happening because it's too small for them to notice.
Gary Mundy, I'm Qualcomm. So this may be a little bit related to Eckert's point, but when I look, if you look at recently standardized and deployed IP multicast over-the-air systems like ATSC 3.0, which do implement live streaming using filecast transport. In this case, ATSC specifically does a flute derivative called route, and I'll be actually talking about the GGIE task force meeting later on this week. This wouldn't be implementable because you're doing all the integrity checking at a packet level. I'm still not quite clear about the argument why you couldn't do it at an object or file level, given that and still meet your requirements as far as live TV services are concerned, unless you're not looking at live services for streaming.
Well, what were you considering? What were you using as transport for live video? Right, we're considering a situation in which you would use multicast maybe within the publisher network, then AMT to tunnel into an AS that has multicast supported natively within their network.
Yeah, so we would be looking at, in that case, we're looking at IP multicast from the broadcaster tower down to the television set, where where the transport is essentially very similar to flute. I forget the RFC number for flute, but I mean flute is essentially a file casting system, and which marries well with technologies such as Dash.
Okay, so what infrastructure does that require in the recipient's network? So this is like a repeater or something?
In the recipient's network, if you're talking about a TV set, it requires a protocol stack. At the transmitter side, at the broadcaster tower, they may be ingesting over the internet, and that may be done over a non-IP multicast. So that might be done over a unicast network, but then it'll multicast over to different TV receivers. Is that not the use case you're looking at, or is that completely different?
I'm not entirely sure. I'm happy to talk about it offline, though.
Okay, but you're definitely not looking at a TV broadcast use case, then, right?
Well, not over the air.
Okay.
Phil Humbaker. Yeah, I spent a lot of time thinking about this problem.
And yeah, we chatted over email briefly.
Well, the way that basically there are many different solutions and many different, but the problem is that it's difficult to come to a generic problem because the solution that you come to is really sensitive to the attack model that you assume and the constraints that you assume. And changing the attack model or the consequence very, very small changes the optimal solution dramatically. So for example, for anything that's static, you don't want to do any of this. What you want to do is to do a Merkle tree, sign the Merkle tree root, and send out the Merkle tree in advance of the packets rather than at the end. Mm-hmm. So that every time you receive a packet, you know whether
immediately whether to, you know, you can authenticate it immediately.
So known data, that's a separate problem entirely. So you're talking about live. And then the question comes up, well, what consequence are you willing to accept? I mean, like, denial of service isn't going to be soluble, because if you've got denial of service going on, all you can do is to shut down the pipe.
Right. So if somebody can drop your packets, then you have
Or
an
if they can
insoluble problem.
But if they can inject nonsense.
Well, if they can inject nonsense, but your path can filter it out, right? So the example threat model we have here would be an attacker sharing the same LAN with a transit point, right? Injecting packets into the ambient intermediate system there, right? So that system would have the ability to retrieve the authentication information from the sender and filter out any packets that don't authenticate. Where with Tesla, that's not possible because they don't have access to the key at the point that they have to move the packets around.
Yeah. Well, basically, I think you need to be hyper-specific about what problem you're solving.
I agree.
Once you do that, I mean, like, it'll become...
Right. I mean, I think I'm more looking... So where we want to go with this is we're wondering what the next step should be, whether this is something that something that the security area should look at in a little more depth, even to decide whether it's worth doing or not. And one of the ideas that Jake and I had was, should we reopen MSEC to look at this? So, Chris.
Yeah, Chris Wood. I just wanted to point out some related work in the IC Energy working research group. They're working on this thing called Flick, this file-like ICN structure, which is basically exactly what you've described with this rolling manifest thing. So it might be worthwhile taking a look at that. I'm not advocating for ICN in any way, shape, or form, just pointing it out.
Okay, thanks.
So just FYI, the citation I was referring to earlier is Golay and Mudadugu from NDSS 2001, authenticated streaming data in the presence of random packet loss. I sent that.
Sorry, say again?
Yeah, it's Golay and Mudadugu from NDSS 2001, authenticating stream data in the presence of random packet loss.
Okay.
So they work out what they claim are the optimality bounds for various kinds of constructions using caches.
That's great. Can you send me
I
the
sent
link?
the list.
Okay, awesome. Any other questions?
Invite Ecker back up to the mic if you'd like to take your privileges AD to suggest a path for this.
I mean, I guess my question before we talk about what work should happen is who's interested in this work? Who'd like us to see us do anything in this space at all? Because that's the threshold question, I think.
Show of hands. Anyone want to express interest here? Got a couple over there. Okay. It's non-zero.
Yeah. I mean, Kyle, let me ask you, like, what are you interested in specifying here? An entire protocol, just the cryptographic construction? Like, what is it it seems like it's halfway in between almost.
Well, our current conception is that the protocol would allow for a broad range of use models, but that the draft would specify a recommended use case, right? Recommended parameters for overlap, or if we decide to go with a Merkle tree, for how that would be constructed. Based on math that actually tells us what the optimal parameters are. So I'm thinking both a specification of a protocol for creating and distributing the integrity data, as well as recommendations on how it's used.
So I think my advice would be to try to find some particular use case where people actually want to do this and specify for that use case, but with generality if you can. And if you can't get that, then I think probably, that's a different question. But I think that, like, I saw some people, I think, with the same community of interest, if I was looking at the names faces correctly. So maybe those guys can form a community of interest with you on a specific protocol that people care about.
Okay.
Because I do think that, as Philip said, I do think that these cases are, the streaming case and the non-streaming case are pretty different. So it may have very different settings.
Okay, thanks.
Administratively, blue sheets. I have one. Does anyone need to sign the blue sheet?
Okay.
So I'm not Ben Kadick. I have literally never seen these slides before in my life. So this is going to be quite interesting. Yeah, thanks. Exactly. I guess the first thing I'd say is I think it has to be clear from this, like, this is not my draft. I'm not a proponent of this draft. I'm the AD who potentially have to manage this draft. Thanks to Adrian for giving us the timeline here. So this is basically, there's this draft, which I don't even know if there's a description of what this is about, but this next slide, awesome. Basically, this is a draft for an enhancement to PKCS8, which I guess I'll talk about in a minute, which the author proposed on SAG before we had, before we had a SecDispatch, and there was not really much interest. Draft was submitted to ISE. You can see this incredibly long thing here. We sent back a do not publish conflict response, which basically said, we'd like to see you bring this to SecDispatch. As you can see, this has been appealed, though not by the proponent, rather by John Clinton. And now we're here. Think of the appeal and this SecDispatch thing as separate things, because I believe John's appeal actually says that. So in any case, appeal regardless, it'd be good to see if this actually has interest in SecDispatch for IETF to take it on.
Right, to jump in, I mean, ISC asked us to bring this here as well, and the EDs did as well.
So, Ecker, do you have a synopsis? Well, maybe after reviewing it. Yeah, I'd be interested to know why the IESG thought this was BMP.
Yeah, I think, well, we do sort of say that slight intertext, but roughly speaking, basically the idea is that it's possible to that you might wish to have proofs that the primes are generated, primes in a public-private key were generated in a certain way, and it's possible to package those proofs up along with your along with your key. That's the private key, and so this document basically specifies how to do that in PKCS8. Right, last slide. Okay, so this isn't in the slide, so I'm just vamping now. But the relevant facts are that because these are OIDs in the slot this is going in is an extension slot in PKCS8, so it's an OID, and therefore there are no writing considerations in the document, and the OID that this is a publication, this particular extension is using Red Hat's OID arc, not an IETF OID arc. So there's no technical requirement this have any interaction with IETF at all. Yeah, present requirement. Thank you. It's not coming out of an IETF registry. However, the IESG felt, and as I say, we have an appeal, so we have an opportunity to reconsider that position, but felt that while it was perfectly fine for that OID to be published and for some other document outside the RFC series to document the use of that OID, that if there were to be things that were effective extensions to PKCS8, which went through the IETF process, and they were published as RFCs, they should go through the IETF process rather than published in ISC. So that was the context in which the DMP was set. I guess but I think the question at hand is this last slide. Oh, good. Is there interest in the IETF in actually doing this work or reviewing it or something, or is there no interest in the IETF? In which case, that can be taken back to the ISC, and then there can be discussion about what to do that. So I think that's. I think this probably is not the place to discuss whether the appropriate relationship between the RFC series and the IETF. We'll do that later. But if people think that the IETF should do this, then that's a different question, and we can have a discussion now.
So, Adrian, I see you lurking in the back there. Do you have any comments you'd like to add? Okay.
Rich Sauls, do we have any feedback, like how good the proof of primality is?
So I'm not an expert on this. Russ may have an opinion.
The one that's proposed here is part of the FIPS.
Right. So one thing I don't know, I mean, like going to the value proposition here, my understanding is people who have badly generated primes generally generated themselves, and therefore probably are not going to be reading the primality proofs out of other people's primes. I'd be more interested actually in prime proofs of public keys, so I can consume them. But my understanding is that's not what this is about.
Okay. Sean Leonard. So as I said on the list recently, I'm in favor of this draft proceeding to publication, and I don't see a reason why it has to go through further IETF process beyond just what it is now, which is ISE. It is in a private OID ARC, and I think that PKCS8 as a container format is designed so that these types of extensions can be made. And I think that Kathleen Moriarty made a similar comment recently on the list too. So.
Sure. Again, just to clarify, that the ISG's position, I think, was it's fine to have those extensions made, but if it'd be RSCs, we prefer them to be an IETF. That other people may feel differently, but that was the context in which the IETF and which ISG made the statement.
So Russ Housley, my view is that we should let this go forward. I think we've aggravated this author by him first coming to SAG, we saying go over there, he goes over there, he brings it back through the ISE, and then we say, oh, conflict for you, no, you shouldn't go forward with this. Basically it's the OID has already been assigned, the context is clear. The only difference is whether we tell the world whether that OID means an RFC or something else. So I think he's engaged with our process, and we ought to just let it go.
So I noticed we had Scott Brewer in the queue. Scott, oh, yeah, there he's back. Okay. Sorry for delaying, Scott.
Hi. I'm sorry. I am just coming out of this completely cold. I just want to comment that the short-Taylor proof of primality is fine, but you can deduce by looking at it what prime you're talking about, and so is able to factor if you're trying to show that an RSA key is actually generated properly. What would be better would be a zero-knowledge proof that is an RSA key had exactly 2 prime factors.
Yeah.
If I'm totally off base, never mind.
Well, my understanding in this case is this is attached next to the
prime.
prime.
Okay. Never mind.
Hi, Stephen Farrell. So I agree with Russ. I think this should go forward in the ISE. I don't at all understand the ISG's reason for saying do not publish. I mean, I guess you're going to deal with that in the appeal, but I have to say it's utterly unclear to me what the justification for that was, and I didn't understand when you just described it.
Okay, would it help if I said it again?
Well, not if you use the same words.
Yeah, sure. I mean, I think, yeah, I think the ISG's position. I wrote that text. So I'm not trying to hide from it, but the ISG signed off with it. Was that having this be an RFC implied something to many people about what the IETF's position on it was, and that given that, so given that originally this came through IETF, that extensions that have RFCs should also come from IETF. Yeah, this is the context of this box, right?
And not to parse your words, Stephen, what we're doing here is just giving feedback to the ISC on what the pulse is.
Yeah. So to be clear, if the position of, I mean, like, we don't need to debate like the ISC part of this right now. That's a different question. The relevant question is, do people have any interest in doing this in the IETF? And if the answer is no, then that's something we can take back to the IETF.
Right. So again, I agree with Russ.
I think we should ship it as soon as possible. I mean, like, given how much longer we're probably going to be using RSA, maybe a decade at least. I mean, like, we don't need to spend 5 years of that kicking this around and then waiting to implement and so on. So just ship it.
This is Barry Lieba. If the consensus is just ship it, what would be the problem of doing a 4-week last call and sending it back through as an IETF document?
I'm going to let Adrian talk if he wants to before I answer the question.
Adrian Farrell, currently the ISE. The point of coming to SECDISPATCH with this document was to hear the IESG when they said, we think that there might be community interest in publishing this as an IETF RFC. I put that on the list, the SECDISPATCH list, a month ago, and I don't want to interpret consensus in your working group, but I didn't hear anybody saying, oh, we're really interested in doing this. In this meeting, I actually heard even the opposite. I heard a number of people saying, just get it out as ISE. Now, if you want to push it through the IETF as a an IETF document, I have no objection to that. I like stuff coming through the IETF. I actually quite like the IETF. But I would really encourage that it happens with at least some kind of process support from the chairs or ADs or the working group. Otherwise, it's questionable whether there's IETF consensus on an IETF consensus document.
Well, I guess what I'd like to hear, and since this is working for me, what I'd like to hear is there consensus here that we should ship this to the ISA? Because that would be useful feedback to us. I think Martin wants to talk before we do that, though.
No, I don't. Thanks, Rich. Martin Thompson, I'm actually hearing that people want to have this published, which says to me that maybe the people in the IETF want to have this published. And proposed standard is better than whatever other labels that might be available. So the only problem is finding a home for it. I don't like AD sponsorship, but I mean, it seems okay in this case. I mean, I'd rather never use AD sponsorship, but if this working group thinks that the AD should sponsor it, then that's actually not. That's actually probably the best way to use AD sponsorship.
I mean, the purpose of SecDispatch is precisely to launder AD sponsorship through community input, right? So, I mean, no, seriously, it's to make it so that we're not just making arbitrary decisions. So, I mean, I guess Ben's not here, and Ben's sort of with the person doing this, but I guess if one of us were willing to AD sponsor this, is this something that the people would want to have do and be willing to review?
So we should certainly kind of test that. I mean, we heard publish it immediately, which means keep going down ISC. We could potentially talk about another round as well, but we should test that.
Stephen Farrell. So I guess I would probably be against making this an IETF document. It just seems to be something somebody has done, and then publishing the IC seems fine. If we want to do something in the IETF, and if there's interest, then I think we'd have to wonder about the cryptographic strength behind this and possible other ways of doing it. And that doesn't sound to me like something that we should do at the drop of a hat really quickly. So I think, for me, that argues just give it to the ISE or really do the work, which I think would take a long time. And you'd involve CF4G and so on and so on.
Yes, I don't know what the authors want, by the way.
So yeah, it seems like the outcome that was proposed basically by Martin is that we express the consensus in this room. We'll take the hum in a moment. That if the ADs are willing to sponsor it, then they can sponsor it. And if the ADs aren't willing, then Adrian has our go ahead to publish it in the independent field. Is that too open ended? You want to constrain it a little more? Mike giving thumbs up?
I think the feedback is people want to publish it immediately. And so is the hum who wants to publish it as INC, yes or no, because that's what's on deck right now. With the appeal process, if there's a yes, that says consensus one way. If there's a no, then there's an exploration of the solution space of what to do next.
This is Barry. May I suggest the first question be who objects to telling the ISE that it's okay with us to publish it? And then depending on the outcome of that, you can consider another question about AD sponsorship.
Sorry, can you say that again for the room?
I suggest the first question ask for objections to telling the ISE we think he should go ahead and publish it.
So how about we do this three ways? We say preferred option is ISE, preferred option is AD sponsorship, preferred option is do not publish.
Sure.
That sound all right? Everyone got that?
Yeah, I guess that makes me a little sad, to be honest. I think, as I said, I think we felt like that it would be nice if it went through the IETF, and appeal notwithstanding. I still think that I still prefer if things that are going to be published as RFCs, they go through the IETF. So I guess I would like to hear, like, are people willing to are people comfortable with having the city sponsored or willing to sponsor it?
I think the outcome of that, if there's some mass in the ISE and some mass in the AD sponsorship buckets, then it's up to you and Adrian to hash out how it ultimately goes.
I get that you want RFC publications to be from the IETF, but that's not the system we have right now. So do it as an ISE and let's get it out the door.
Quickly, when you wrap this up. Yeah.
Just on the humming question. So if you're going to ask, can you also include a way to say that if people object to it being handled in the IETF as AD sponsored, not just preferred?
And I should probably have clarified my position. I think my position was intended to say, as I said earlier, that I think that publications that touch the IETF protocols ought to become, that are RFCs ought to be IETF RFCs. Was I think what I meant to say.
This is Pete Resnick. I doubt Adrian will say this at the mic, but I want to be clear that whatever this group says, Adrian can say, screw you, I'm publishing it anyway. And can just go ahead and pull the trigger. It's a courtesy for him to ask, but we are not making a decision for him. Let's be clear on that.
That's my understanding of the process as well.
Absolutely. All right. So in light of Stephen's comment, we'll do it 5 ways. Multiply everything. So we'll have, I'm okay with ISE, I object to ISE, I'm okay with AD sponsorship, object to AD sponsorship, and don't publish this at all. Okay? All right? Do it how you like it.
Yeah. I mean, I want less hums, right? I want ISE publication. I want AD publication. I want something else in IETF. I object to this work at all. It only gets us 4 hums. Okay. All right. So let me, again, the options again, I'll speak more slowly. We're not typing it on the screen. The first hum is going to be, I want to publish this draft as ISE. The next hum is, I want to publish this as AD sponsored. The third hum is, I want to publish this in this some other way in the IETF. Fourth option is, we don't want to publish this at all. Okay, so the first hum is, I want to publish this as ISE. Okay, the second option is, I want to publish this as AD sponsored. The third option is, I want to publish this somehow in the IETF other than AD sponsorship. And the fourth option is, we don't want to publish this at all.
Thank you.
It's clear. So what we heard was that there was a clear preference for option number 1, which was publish as ISE. Okay.
Oh, I get the clicker.
We're running a little behind time, so Philip.
Okay, so this is what I talked about at Hot RFC date. Data at rest encryption, DARE. We came up with the acronym, and so we had to have a draft. Okay, so PGP and SMIME are really good for the things that they're designed to do. They're not really designed to encrypt data that comes to you one chunk at a time. In that the only way you can do it really is to do a sequence of open PGP messages and then have some sort of way of turning them into a sequence, and it's big and it's bloated, and you don't get any cryptographic return on that overhead. So DARE container is a way to do incremental encryption. Yeah. So it's doing incremental encryption and authentication. So you have an append-only log. You only write things to the end of the log, and you have an authentication mechanism built in, or rather the option to do authentication. You can hash each item as you add it. You can do chains of digests across the sequence, or you can do a Merkle tree across the sequence. And these allow you to do rapid authentication of the entire log from a single signature, or to sign individual records in the sequence. And it gives you the same capabilities of something out there called clock chain or something. You also have the incremental encryption. So you can do a key exchange, and then you can apply that key exchange to one record, a sequence of records that are contiguous or even non-contiguous records. So one way that you can use this is, say, a server is using this to encrypt its log files.
It starts up. It doesn't have any ability to read its own logs because it doesn't have the private key. It's a write-only log for the server. It does a key exchange when it starts up, writes to the log. When it reboots, new key exchange, starts writing. You could even have two processes writing to the same log at the same time, and provided you stay within the 4,096 bytes that the operating systems provide you atomicity with, the two won't interfere. You can't do Merkle tree or the hash chaining with that, though, but yeah. So this allows you to have encrypted attributes or payloads. So it's a little bit more than you get from CMS or PGP. Okay. So efficiency, this has been designed so that all operations are going to be log n or better. So when you open up a container, even if it's got the Merkle tree, it's never going to be worse than a log n operation to open that container. Appending a record is always going to take you unit time. Read efficiency is going to depend upon the container type, in that if you formed a tree index over the container, then you can you can do random access in log n time. If you haven't, well, you're going to have to read the whole sequential container. And whether or not that matters to you really depends upon your application. And you can also choose the encoding. You can actually do this in straight JSON with no binary encoding whatsoever. I don't recommend it, but you can. The technology, well, it's basically taking JSON web encryption and JSON signature for the crypto. There's some reorganization of the tags to make it smoother, but the semantics are unchanged. The binary format uses frame headers that are designed so that you can read the log file equally quickly in the backwards direction as the forwards. And that's really important for log files, because usually when you're opening up a log file or a message archive or whatever, it's the last 10 items that you're interested in, not the first 10. And so basically what we do is that we have a variable length encoding for tag length data, and we basically write the length prefix at the start, and then we write it backwards at the end, and that allows you to know the frame length regardless of which way you want to read the data. So this is the way that we traditionally do our key exchange in SMS or PGP. You have your public key information, you have your encryption key, you have your plain text, and you have your initialization vector. And that's all the data that you provide in the encrypted message. Then you go through the key exchange and you spit out a public key identifier, recipient information, your ciphertext, and you give the user the initialization vector. Okay, so we're doing it slightly differently here because we want to be able to amortize that key exchange over multiple messages and multiple data sequences. So the first thing we do is that we do that key exchange as usual, using the public key information, and we give so the recipient's going to get the public key identifier and a series of recipient information blobs, and those allow the recipients to decrypt a master key for that particular key exchange. So you can do key agreement, you can do RSA, whatever, but the output of the key agreement is one master key. And then to apply it, could you shift this up a bit? So to apply it, each time we want to apply this to a message or an attribute on a message, we generate a salt, we take the plain text and the master key, we apply those, and that gives us our ciphertext. So the only thing that we actually need to tell the user who's decrypting is the salt and the ciphertext. Sorry, I just realized that the salt should have carried across onto the sequence output as well. We use HKDF, the key derivation function that we use in other protocols, to generate both the encryption key and the initialization vector. So we don't allow users to generate their own initialization vectors, which is something that I've not seen done before, but is kind of logical to me. I mean, the less things you allow the user to generate, the better, because the less randomness you're moving around. So this allows us to reuse the same master key multiple times, because every time we apply it to a new data a new data sequence, we will automatically get a new session key. So what's it for? Well, one application is to archive a website offline in an encrypted format. So you can web a website, you can put it into one of these containers, you can sync it onto, say, a USB key, and if you're in parts of the world where the web is censored, that gives you a very easy way to surf the web in minimal time. Originally, it was designed as a lightweight persistence store. So I've got these messages, I've got bookmarks, I've got credentials, I've got calendar. I want to be able to store those all in a file format that allows me to add additional items into the persistence store one at a time without having to re-encrypt the whole thing. You can use it for encrypting server logs. And this is what has turned out to be the thing that I was told by my marketing department that they were interested in, because we've got all these server logs across our infrastructure, and they're actually on 4 different continents. And we've just been told, well, they're all within scope for GDPR because they're all tracking IP addresses. So we should have control over them. And so this is a way that you can get control over your server logs. It's not going to mean that you are GDPR compliant, but it's a good way to start getting there. And of course, the other way that you might want to use this is anytime that you're told to do something on the blockchain, this actually gives you what you really probably wanted in the first place. So what I'm really coming here to do is to show it to people and see what they feel that they should do with it. And hopefully to get people to look at it and review it and tell me if I've got the crypto wrong. You can tell me if it's right, but if I've got it wrong, that's even more useful. So basically, the thing is that as soon as I start using it, I'm kind of like going to be generating legacy. And so I want to record what we're doing here in some format. So whether that's AD sponsored or an independent submission or whatever, I want to describe this content format in a way that you know, folk who are trying to decode the containers can see. And the question is whether people are interested in this to the point that they'd like to work on it and form a working group, or whether I should just do it or whatever. And of course, yes, the 3 key cryptography things I presented at previous IETFs, I'm still working on that, and using the multiple decryption key, the split decryption key cryptography is one of the reasons that we invented this format for. But that's not what I'm presenting it here, and I'm quite happy for people to say that they'd like to wait until I've got that as well. This particular container format is not tied to my particular key management. You could use PKIX for it, you could use PGP keys, whatever. It's agnostic because it's based on JSON web encryption and signature, and they're open systems. So, questions?
So yeah, well, so while Stefan's coming up, one minor observation, you might take a look at the AES-GCM SIV work that CFRG has been doing. It's a synthetic initialization vector. So it does this thing you were doing where you don't let people choose an ID. And it has a whole framework for it that's been reviewed by CFRG. So that might be a good component.
Okay, I'll take a look at that. I mean, I noticed after I started to apply this, somebody came up with an attack that uses manipulation of the initialization vector. And I was kind of like, ooh, it's actually...
Stefan, please.
Stefan Satterson. Is there any IPRs around this?
I am not aware of any IPR on it. The Harvester Netter patent on catenate certificates has expired several years ago. The Merkle tree patent has expired.
I'm not aware of any other patents. I mean, that doesn't mean that there aren't any, but I'm not aware of any.
This is typically areas where there are a lot of patents around. So, but have you looked through it and made your best effort?
Yeah, I mean, like, you know, my main business is as an expert witness in patent defenses. So the work that is similar to this that I'm aware of would be the Cryptolope stuff from IBM, and I believe all those patents have expired because that's over 20 years old now. I think that the reason that we've not done something like this before was because the Harvester-Netter patent stopped you doing the digest authentication chaining. But the encryption piece, I mean, basically that's the TLS key exchange, but applied to static data instead of dynamics. So, you know, I think that there's strong prior art for it. That doesn't mean that there isn't a claim, but.
So Philip, you present a broad spectrum of kind of options. What might be interesting to hear is how much interest is there for kind of this work, and that may guide us.
Has anybody read the document?
Brett Jordan, I like what you're doing. I like this. It has real potential, especially in the operations space. So thanks.
Yeah, I mean, if you go to mathmesh.com, that has the drafts with actual diagrams in. So, I mean, like, you know.
I appreciate your use of the new draft technology there. So, yeah, can we have a show of hands of folks who have read the document? 1, 2, 3. There's. Okay, so it looks like you might need to kind of build a little bit more community around this. I don't. Given that level of interest, it sounds like there's you were kind of conceptually interested, but
yeah,
you might need a little more momentum here.
Yeah, I mean, you know, it is the first time I've shown it. So
yeah, great, thanks. All right, I think Mike Jones is our last speaker.
Good afternoon. I'm Mike Jones from Microsoft, and I've written a little draft to help some people in some communities that I'm part of, including the W3C and FIDO, use some standards from the IETF with cryptographic algorithms they want to use. In particular, the draft in question has 4 IANA registrations, 2 curve identifiers and 2 algorithm identifiers, 1 each for Jose and Jose. That is all it does. It registers identifiers for the curve and signatures using that curve for the SECP-256K1 algorithm that, among other things, was described by Dan Brown and Certicom in the SEC2 publication that a number of you are familiar with. This algorithm is used by FIDO UIF, the W3C Verifiable Claims Interest Group, several blockchain projects. And my goal is pretty simple. Right now they're doing ad hoc crypto representations, and I want to have them start representing these data structures using IETF cryptographic standards that many of us have worked on. So there's a backstory about why I had proposed this becoming an RFC. Those of you who are familiar with COSI and the associated IANA registration procedures will recognize that for the very small integers in the -24 to 23 range, those are what's called standards action required, meaning that only an RFC can do that. Because this is an algorithm that will be commonly used for a lot of particular kinds of projects, I was seeking a path to make this an RFC so that the COSI integers can be small ones. Now, Ecker did point out an alternative, which is rather than using an RFC to register this, we could change the registration procedures for COSI and let it be document required and leave it up to the designated experts whether the particular assignment merits use of the small integers or not. And it turns out that there's a current precedent for this. There's draft IETF TLS IANA registry updates, which lets people register TLS algorithms, I think, without using an RFC in some cases. So the backstory quickly is I'd asked Ben about AD sponsorship. He suggested I bring it to our new SecDispatch working group, which we've done. There's been discussion on the list. Michael Richardson, are you here, Mike? Volunteered to shepherd the document, helpfully. Philip suggested adding a table of cross-references for other identifiers for this algorithm, including OIDs, which are already assigned. I said that's a good idea. Ecker suggested that I ask the CFRG for feedback on the curve before we consider taking action. Dan Brown, who wrote the original publication, provided a pretty useful analysis of pros and cons of this particular curve. My layman's interpretation of it is that there's no known practical attacks against the curve, so there's not a security reason to prohibit its use. As a process point, I will point out that this will not be the last such draft, that its purpose is to register identifiers for algorithms. Indeed, the reason we have the Jose algorithms registry and the COSI algorithms registry is exactly so that you can keep using those data structures, but with new formats. I'm aware of some work, for instance, where people want to use some of the cha-cha and salsa algorithms, and assuming they pass muster, we should be able to do registrations for those. My draft only does one algorithm, which there was an immediate need for, in part because some projects I care about are currently doing ad hoc crypto, and I'm telling them, you should stop doing that. We should be able to use Jose for your use cases. This is the last slide as Russ walks to the microphone. It seems to me like some of the choices available are AD sponsorship, which would be expedient, and ask Mike to shepherd, or I would be willing to write the draft relaxing the rules, in which case the W3C could just publish a W3C document and ask IANA to do the registrations. There may be other choices, but that's all I had to say in background. Russ.
So if the area directors would be willing to take on the third bullet, I think that's the best way forward. So that we have roughly the same bar for registering a TLS algorithm or an SMIME algorithm or an IPsec algorithm or on a cross. So I think having the same, you must be this tall metric across all of those makes the best sense.
Okay.
Dave Waltermeyer. So there's other crypto algorithms that have been considered recently around COSI, like Russ's hash signature draft. I was also talking with some folks about some missing NIST algorithms in COSI as well. We might want to consider establishing some kind of COSI maintenance working group that's maybe chartered narrowly to focus on crypto only as a way to work on these kinds of issues going forward. So I think that should be another possible option.
I would point out that if we did such a thing, it would need to be scoped to at least Jose and COSI, because you would want to do parallel registrations from the same drafts.
So, Martin Thompson, I had a couple of questions. I can sort of see the path towards something like the ECDAA stuff that's used in FIDO. Obviously, that's a completely new algorithm. It has some utility in particular context, and we don't have any real equivalent. But we have an equivalent here. So why is the P1 option not a good one? Just for my gratification.
It has, in my
mind,
mind, and I'm not an expert, more to do with sociology of the engineers involved and their belief systems than particular engineering choices. I firmly believe I will not be able to dissuade some of these projects to move off of these algorithms. I made them a promise that I would attempt to let them use standards with these well-known algorithms rather than have them have to be off in an invented land that has no real peer review.
So
I'm trying to bring them into the fold.
Understood. That is a fair point, and we shouldn't necessarily force these people to go elsewhere as a result. But we're not forcing them into a ghetto. We're forcing them into using a 2-octet encoding for their identifiers rather than a 1-octet encoding for their identifiers. How is that a problem?
That particular point is, debatable whether it should be a very short or a short identifier. And I could personally go either way. I wanted to be able to, in good faith, request the short kind to the designated experts and leave it up to the designated experts what to actually assign. If I don't have an RFC, then their hands are tied about whether it makes sense to use the short identifier or not. This is the most commonly used algorithm in the blockchain world. Whatever you think of that, and we could have beers about that, but we're not going to take them off this algorithm.
So,
if you're paying, yes.
Yeah, can I have a call for consensus on that?
Yeah. So, I guess my point here is that we've done a lot of work recently to sort of narrow down the set of recommended algorithms that we use in protocols. And
Which I support.
While we're not in the business of telling people that they can't use algorithms that they want to use, and obviously we are not going to go off and persuade people in the blockchain world. I like using that word. It's great. To change their minds about what it is that they use. We did kind of create this carve out in COSE specifically because we wanted to make the set of, for want of a better term, the recommended algorithms that we say to use is a fairly narrow set. And this would essentially reverse that.
Well, and there is a slot in the registry, thanks to Sean Turner, where you can say recommended, optional, deprecated, prohibited.
Right.
And I am not trying to make this recommended. I'm trying to register this as optional.
And you could certainly do that. It's if the only reason that you're going down this path is to save an octet in the identifier,
No, you're conflating two things.
Right.
I'm going down the path of writing the draft at all to bring these people into the fold of using IETF standards for cryptographic representations. It is sort of an asterisk on the side whether we do the work to let it be a short identifier or a medium-sized identifier. That is not the higher order bit. The higher order bit is registering identifiers for these algorithms so that people will start using Jose and or COSE rather than ad hoc crypto formats, which is what's actually happening.
So there's a number of points that I was trying to get to and probably should try to pull them apart a little bit. I don't think this needs a 1-octet identifier. I do think that we should have registration policies that are consistent across all of these different spaces because they're basically the same things. It's just the TLS code points, the PQX code points, what Jose code points, they should all follow relatively consistent registration policies. Otherwise, we create some weird side effects. But this point that we're pursuing seems a little bit too much for me. If we do this third point here, which I guess I'm pushing towards,
And I'm fine with that.
Then the problem's solved. Let's do that.
Ecker, since you're at the mic and it was your idea, would you sponsor that?
So as I understand it, that what you're suggesting, I guess depends what you're sponsoring. So I understand that the current state of play is that the 1-byte identifiers require standards action, and the other ones require, and that the 2-byte ones require specification required, and
Right,
the 3-byte
which the W3C could just do.
right, and the 3-byte one.
Keep going.
And anything longer is expert review, right? With apparently no specification, perhaps, right? So what I'm trying to understand is, it seems to me like if they want a 2-byte identifier, why can't they have that right now without doing nothing? Does the specification required say it has to be an RFC? So
Standards action required is an
that's
RFC.
for 1-byte, isn't it?
Yeah, that's for
So I guess my
1 byte.
point is, if they want a 2-byte identifier, can't they just register it simply by filing with IANA right now?
Where is their documentation? Yeah, presume it's on a web page.
I wrote the only document that exists for this. We could decide to do this, and independently that I could change it to a 2-byte identifier and proceed.
Right, but Ecker's point is that if you just put this in a permanently accessible web page somewhere, you can go through specification required and not have it published as an RFC at all, and still get the registration.
I know that, and W3C WebAuthn is willing to publish such a web page.
So I guess I don't understand why we need to update the registry. That's the part I'm confused about.
We need to register algorithm identifiers for them to be able to.
No, sorry. Why
with IANA?
Why we need to do why we need to update the registry with a draft? That's the part I'm confused about. What are the rules now say? It says specification required, right? So that would incorporate. That's the part I'm not. I feel like I'm not understanding. I can't even give an opinion because I don't understand the context.
So let me test the understanding kind of everyone. If I want a 1-byte registry, I need an RFC.
That's right.
You need a standard. No, you need a standards action.
I need standards action. Sorry. If I want a 2-byte, it's specification required, anyone's specification, W3C or otherwise. If I do 3-byte, that means I need expert review. So I think the question is, again, correct me if I'm getting it wrong. Option number 3 says we need to change how we do registration and coding. That means governing 1-byte things as well, because I get that already with 2-byte and effectively 3-byte. Correct?
Correct.
So right. So I guess what I understood.
Well, the upshot of that is there's basically one of the other possibilities is use a 2-byte code point for this and take no other action.
Which I heard Martin saying. So I guess that's why I don't understand what is being asked of me.
You'd suggested number 3.
I think I did. I guess quite possibly. I guess I meant I quite appreciated this 1 versus 2-byte issue. I mean, I guess like my personal view, I guess I'm not sure which hat I'm wearing right now, but I'll try to talk anyway. Is like, I don't know how scarce these 1-byte identifiers really are. If they're like super scarce, then probably it lines up with the recommended column, in which case you shouldn't be allowed to get one without recommended. If it's like not super scarce, then like I'd be willing, and the COSE community wanted to make it easier to get 1-byte identifiers, I'd be happy to sponsor that.
There's 48 of them.
Yeah, the point of all of this, the constrained environment community has gone through pains to conserve those sorts of things, and that's why that's set up as standard action. We would not want to change that policy.
Yeah. So, Martin Thompson, just to Mike's point there are 48 of them. Why they decided that negative identifiers was a good idea it completely escapes me. But there are 48 of them. But the registration policy for standards action required extends to -256 and positive 255 for some reasons that again escape me. It's not even symmetrical at that point.
So, all right. So does anyone? So I feel like there's several people proposing the 2-byte identifier, no other action course here. So anyone who wants to stand up for another course of action. All right, hearing none, it sounds like that's where we're going.
Okay, I'll report back to the W3C and the interest groups. Thank you.
Thanks, Mike. And that was the last thing we have. We have a couple minutes left. If there's any other business. Last call. And we are adjourned. Thank you.
And thank you, presenters, for keeping us within the time bounds.
I'm well aware of it. Well aware. It means it's going to be interesting.
Yeah.